Hello. Happy Wednesday, everybody.
Everyone.
Not sure if it's Wednesday where everyone is at, but it's Wednesday where I'm at.
Correct.
Looks like we're getting a lot of people joining us for the webinar. I'll give them maybe a few seconds to pop in before we get started. Today's webinar, though, is about precision in preventative maintenance, and we're going to be talking about how to craft effective and repeatable tasks.
Yep. We are going to talk about big picture buckets of how we can structure our thinking and our strategy when we start writing actual tasks. Not, my whole PM strategy, right? But the tasks within our PMs. What are the big bucket things, some of the things that a lot of people overlook, and how can we get more structured and standardized where everybody can participate effectively and efficiently in our PMs and not just the most senior guy, right?
Yeah. All right, let's go to the next slide.
All right.
All right, so again, welcome everybody as you're joining us. Here's a few tips for you during the webinar. So if you have any questions, there is a little question mark icon on the platform here. So if you have questions and you put them in there, that's like the best place to put them, because then we definitely are going to see your questions there. We also have the chat feature, which you can put questions in the chat, but sometimes we get so many comments that we lose them. But chat is how you can participate within the conversation. We are going to have a couple questions throughout the webinar that we're going to want to ask you all, and you can type your answers in the chat. All right, so let's test it out. People are already using it, but let us know your name and where you're joining us from in the chat.
We have a lot of
Actually, we can see your names. You don't need to tell us your name, but you can tell us where you're from.
A lot of names that I recognize. Wisconsin. Oh, they're just coming in. I can't even see it moving too fast. Arkansas, Texas, Canada, Calgary. That's too many. You guys are crushing it.
Tulsa,
New Zealand.
Ooh.
We got Greg Christensen in there, Upkeep Ambassador. We got Ahmed, also Upkeep Partner.
Ooh.
Arizona.
Oh, Salem, Oregon. Katie's from Salem. I'm from Eugene, Oregon. Brian,
Okay.
where are you at?
I'm in Maryland.
Yeah.
Another New Zealand, Pittsburgh. Oh, Pittsburgh is I love Pittsburgh because of the history of steel making, and I love antique tools. Jersey, Oklahoma again. Illinois. All right, we got a lot. We got a lot of people.
Yeah.
We're
really happy you guys are all here. Let's get into the webinar here. So, yes, we are the speakers today. It is myself and my colleague Brian. Brian, do you want to give them a little introduction?
Sure. I'm the head of community and partnerships here at Upkeep. I've just been turning wrenches. I've been a maintenance supervisor, maintenance manager, maintenance director, and executive leader in maintenance. I've led a bunch of maintenance departments. I've turned the wrenches for the last almost 20 years. Naval veteran, turned wrenches on aircraft carrier. And that's enough about me. Go ahead, Amissa.
Thanks. Yeah, so I am Amissa, the senior marketing manager at Upkeep. As far as my relevant experience, I am CMRP certified. So I have my certified maintenance reliability professional certification through SMRP. Also, earlier in my working career, I was an operator in a manufacturing plant. So I do remember what it was like to actually run the equipment and the machines in a manufacturing setting. And then also what a huge deal it was when we had downtime. It was basically I remember it was a huge deal. And the maintenance people running around with their heads cut off when we had a downtime event. So anyways, I do have some relevant experience, and I'm really happy you guys are here to talk about preventative maintenance tasks.
Very important.
Yeah. So our agenda today, first, we're going to do an overview of preventative maintenance tasks, just to level set. I'm sure you guys all know what they are, but we're just going to level set. Then we're going to talk about developing effective PM tasks. So we're going to talk about things like context, age, and environment. And then we're going to talk about what good looks like. And then Brian is going to go into more detail on writing PM tasks for repeatability and detail. And then we should have time for Q&A at the end. So make sure if you have questions, type them in the questions there, and then we will get to those at the end. All right. There you go, Brian.
All right. So as I said when we were first coming in here, this is a high level understanding of often missed characteristics of PM tasks, right? And we want to touch on all the things that can add extreme value to your team and particularly your technicians to create that repeatability, that detail, understanding the way your machines operate, where they operate, how old are they, and what things should we be looking for, and how to maintain and create those tasks that are associated with all those different variables. So intro, great. We know what PMs are, preventive maintenance, right? We do those to maintain the inherent reliability of our machines. So we're going to create effective PM tasks. It's for optimization of equipment performance. We want to sustain uptime. We want to have a structured approach. We want to standardize. We want to reduce human failures and improve efficiency. Key there is human failures. Humans are the biggest variable in a maintenance department, and we often induce failures into machines by not doing the correct things or not understanding what we're doing, right? All right, so task challenges, right? We have balancing detail with usability, right? I want to be super, super detailed in what I do, but I also want to make sure that it's transferable to all levels of a technician's understanding or to the appropriate information that's available, right? We don't want to be too cumbersome to slow them down, but we also don't want them to be too complicated and then we're not getting what we need, right? Standardization across teams. We have varying skill sets, like we said. So we want to make sure that the task and the structure is appropriate for all levels. And we'll talk about some good ways to understand those levels. And then avoiding over/under maintenance, right? The best way to do maintenance is at the right time, at the right cost. You know, there's a whole bunch of rights we can say when it comes to performing maintenance, but we certainly don't want to over-maintain things, and we certainly don't want to under-maintain things. Okay, PM task benefits, right? All of us in this chat, we all know what's important. Hopefully you understand what's super important for your specific assets, your machines, your operating environments, your systems, right? So we want to increase inherent reliability, right? So if you have degraded machines, your reliability is suffering, we want to try to get it back up to that design reliability. And of course, through that, we're going to create uptime. So we structure our PMs to mitigate failures. And we want to have unexpected or less unexpected breakdowns so we can improve our availability for our operations. Improved efficiency and consistency. That goes back to what we said before, right? By eliminating variables, inherently we're creating better availability of not just our maintenance tasks, but our machines. Variability is the enemy of a maintenance department. Cost-saving resource. So cost savings is a pretty much a guarantee. If you're doing all the right things, you're going to lower your wasted resources. You're going to lower parts consumption costs because you're going to be changing them proactively, and you're not going to have failed things and reduction in inventory, right? Everything becomes more cost effective when we're doing the right things at the right time, and maximizing our resources, which includes manpower, which is a huge one. Manpower is arguably one of the biggest wasted resources in a maintenance department. We'll talk about that, Greg Christensen. All right. What's your biggest challenge with PM tasks at your organization?
Yeah, this is time for you guys to chime in the chat. Let us know what your biggest challenge is with PM tasks.
Is it the words that they use? Are they written by somebody who's not even at your facility? Are they not putting pictures? Are they not calling out parts kits? Are they not giving you diagrams, right? What is it? So we got details, of course. Yeah, details a huge one. Storing previous PMs, that's a good one. Too generic, oh yeah. The availability of the machine, okay, that's planning and scheduling. We're not talking about that this time. PM scopes are not clear, right? So like, why am I doing this? What's the reason? What's the benefit? So many tasks.
Too detailed?
Too detailed. That'll kill you. Incomplete. All kinds, so many tasks. Yeah. Getting the system in a way that meets, it just went too fast. It works for us. There's a lot here. Management do not believe in PM concept. Well, you will continue to spend money. Repetition and closing out tasks. Oh, Angie, we're going to talk about that. I got a good tip for that one. Frequency of tasks. So I'm hearing a lot of planning, scheduling constraints here, not specifically task constraints. So remember, there's a difference, right? Old template, not updated, new equipment. Ryan, that is so common. Super common. All right. Excessive PMs that are unnecessary. Yeah, that's the name of the game. We see that a lot. We think, and organizations think the more PMs we do, the higher our availability will be. That is not true. Oh, Caitlin, two, not enough time to complete. No value added PMs. Bingo. Value. PMs should be targeting failure modes, right? All right. Great answers, all from start to finish. These are all wonderful. Okay, let's jump into it.
Well, not wonderful, but
yeah,
common.
yeah, not wonderful, but you all clearly are recognizing that there's an issue, and I hope, and we'll talk about this too, I hope that these issues that you are experiencing, you never shut up about to your leadership. Okay. Let's talk about number one, big picture, context. And of course, if you guys know me, I am a heavy equipment junkie. So all my examples in this are D10 cat dozers. Okay. I spent majority of my time on heavy equipment. I love it to death. So I'm using these as these examples. So machine context matters, right? It sets the atmosphere as to how machine is being operated and what systems are being stressed and others relieved, right? So the type of work that our machines are experiencing will dictate how we maintain them, and ultimately the tasks that we're going to create to maintain these machines. So here's an example. If we've got a D10, number one, performing pile maintenance. If you're not familiar with pile maintenance is, it means you're just grooming piles to ensure that they have the appropriate angle of repose. There's no snail trails. There's no dirt. There's no nothing around, right? We're grooming piles, generally light work for a D10, okay? And number two, D10 number two is ripping frozen ground. If you're familiar with rippers on the back of dozers and ripping frozen ground, you will know extreme amount of wear on those machines, okay? So that's our examples. So D10 number one will have arguably less load, wear, and potential for failure, right? We're going to have to clean the tracks. We're going to have to make sure we check all the fluids, the general systems, make sure there's no accumulation. The cooler groups are not plugged up, whatever. Very low risk, right? And then D10 number two is going to experience very high load. The dozer is going to be down in the lowest gear. You're going to have that ripper in the ground, the ripper shanks coming under a tremendous amount of load. The hydraulic circuit is extremely stressed. The torque converter, the transmission, the final drives, the tracks, everything. So you have a much higher failure risk associated with that context of work, right? So we know we're going to have to look at these machines a bit differently when it comes to writing tasks. So with D10 number one, we can likely get a general inspection that covers most machine systems, cleaning, adjustments, general service, inspections, whatever. D10 number two will have a more involved inspection task to accommodate for that increased work, risk, and specific systems being stressed. The reason I put this in here is because our machines, and a mobile equipment is a good example because it can do a lot of different things, right? You may have machines that are in one specific context, right? Which is what you should leverage when you're building your tasks. But everything is seeing a different amount of wear, risk, stress, and we need to be able to understand those risks and what those things are doing in the context to then have them called out in our PM task. The next big bucket is age. And I'm sure a lot of you on here are experiencing age-related fatigue, failure modes, or generally just our company doesn't buy new stuff. We maintain old stuff forever, which I'm not going to argue with because I love old stuff. And I think old stuff is very robust. It's just sometimes it comes to the efficiency of it, getting parts, having to have a tool and die shop in-house to make things for it or whatever. You guys know what I'm saying. Okay. Age. Machine systems age just like we do. We break down, our machines break down. And how we maintain or delay that aging can have a big impact on its cost-effective, useful life. Okay, you got a machine that's 20 years old, it's likely that it's going to see a different amount of preventive maintenance or corrective maintenance or tasks associated with that machine. And conversely, a 1-year-old machine would have a different age-related understanding, right? And that goes for operating hours too. So newer machines may have less hours. Older machines might have more, or flip. I used to have machines that were very old, but were very underutilized. So we were doing different types of work on those machines. So in this example, D10, again, we have 2 years old with high hours versus a D10 with 10 years old, which is low hours. So while newer has experienced more work time and wear, therefore will require more hour-related service or inspection tasks. So if you guys are familiar with heavy equipment, it's generally 250, 500 hours, 750,000, 2,000 hour services, depending on the system. And component replacements such as engines, final drives, transmissions, drop boxes, axles, whatever. And for pro tip, if you're managing heavy equipment, fuel consumption is a very good indicator of wear and service life on components and engines. Keep that in mind. And then detail number 2, higher age but lower hours. So we're going to be looking at time-based service tasks that address corrosion, UV damage, batteries, a multitude of things of machines sitting and not being used, whether it's water and humidity accumulation in gearboxes, it's humidity effects on motor windings and exposed metal, right? So this is an example of looking at those things. If I've got a 980M wheel loader and I have a 980H wheel loader, one is much older than the other, we need to pay attention to that when it comes to building out our PM tasks. So based on age, right? We can look at age in time, years, throughput, tonnage, etc., whatever, right? Taking into account will create a cost-effective tasks in creating alignment, repairs, replacements with your operational needs. So keep that in mind. I love heavy equipment, so we're going to talk about it again right here. All right, environment. Environment matters. All of you in South America or overseas in deserts and tropical climates or up north in extremely cold environments, right? Those things are going to weigh on the way our machines wear and how we operate them. So we got to look at that when we're writing preventive maintenance tasks. So lastly, the environment matters. Machine operating extreme climates conditions will have specific inspection criteria. The difference between hot, cold, wet, or dry can be a deciding factor for an effective preventive maintenance task. Right? So we can't just say because I got a D10 in Antarctica and I've got a D10 in Wisconsin that we have the same PMs, the same inspection criteria, right? We can't do that. So environmental changes will greatly impact asset life, so much so that many machines have design and operational characteristics that are environmentally specific, right? If you're working in a high-speed production food manufacturer and you have perishables, you're going to have machines that are meant to work in cold environments, right? Because you're going to have cold storage rooms where you're packing out equipment or you're boxing lettuce or whatever, right? Conveyor belt materials need to be the correct type of materials. We need to use the right type of lubricants, the right type of steels, right? Passivated stainless steel and all that kind of stuff. So the environment really matters. And here's my other D10, my last D10 example, which is D10 number 1 working in the Arctic, right? Versus a D10 working in a hot coal pit or maybe a slag pit out of a mill or something, right? So D10 number 1 will have specific systems installed on the machine to operate in these harsh conditions, such as block heaters, robust starting and charging systems, and extra operator comfort. Those are additional types of accessories or machine applications that are going to need to be addressed, right? If we've got a guy in the Arctic, well, we need to make sure that his climate control systems are working properly. So that's going to be a prioritized task on the list. And then D10 number 2, we're going to be paying attention to cooling systems, cleaning and accumulation. We got to worry about dust packing. We got to worry about our final drive seals, corrosion and abrasive atmospheres, right? So we're looking at these things very differently, and they will have task-specific inspections. You're going to hear me say that a lot. I'm just trying to build these 3 big categories that are often overlooked. So based on the environment, we know that these several factors will affect the way we perform maintenance, right? So we need to take them into account. Context, age, environment are 3 big buckets. The only bucket above those 3 is the design. We will also talk about that. Okay, we'll stop here for a second. What does good look like? This isn't a question. You guys can respond if you'd like, but how many of you have actually even been told or shown how your machine should be operating in its defined context? Who has said, I'm making up a name, Jimmy, this is the way this bottling line should function from start to finish. This is how this sensor works, and it trips this is how the conveyor works. We should get this many bottles off the line at this amount of time. This gearbox takes ISO 46 fluid. It should spin at 700 RPMs. These are the type of bearings. How many of you have actually even had that told to you? I'm pausing a little bit, Amissa. I'm just very curious. So you said supplier, vendor training. I mean, it could be anything. It doesn't have to be, I mean, it could be from anywhere. We often find that people maintaining the machines don't really get the training on things, how they should work. You have to know what good looks like to inherently know what bad looks like, right? Yeah, Angie, go there. Mine is on the fly. That's what most people get. They get, okay, it's broken. It's not doing the thing that they said it was supposed to do. How do I get it to do that one thing? But how do we know that that one thing is the right thing, right? So we want to first understand, what does good look like from our assets, right? Whether it's performance, whether it's output, throughput, capacity, whatever. Okay. Understanding what good looks like helps identify operational issues beyond maintenance, right? Like improper operation, faulty procedures, right? So we want to create and understand that alignment about how everybody impacts that machine. Establishing a benchmark for machine performance ensures alignment with maintenance strategy, right? And it helps the business understand what good looks like. I've gone and inspected people's machines and they go, yeah, we're not getting the capacity we need out of this thing. And then you look at the design characteristics and they are getting the capacity they need. Just no one knew that it was not supposed to be that fast. So they're beating their heads against the wall trying to maintain, fix, and do all this stuff to something that will never be that fast. So we got to understand what good looks like. Okay, we want to define desired outcomes, right? What does it mean? Machines should meet specific outcomes like production capacity, service life, load, material movement, and be aligned with the bigger business goals and maintenance strategy. Hopefully, the machines were selected, designed, modified, whatever, to meet that RF or that RFQ or RFP, and they meet the factory acceptance testing that they're supposed to, right? All right, here's an example. We want to consult design intent. So we go back and we say, okay, what was this thing actually supposed to do? Whether we got to get a hold of the manufacturer, our engineering team, look at the historical operation versus the current operation, and establish a baseline. This is just a generic picture of a specification sheet of just a random machine. A lot of times, the operations manual or the maintenance manual will have this in there, especially if your team designed or purchased the machine for a specific thing. Like I said, it has to meet the request for proposals, and it has to meet the factory acceptance testing. But this is just an example. Consult the design intent first so we know what good is so that we can maintain to that good. Physically inspect. You hear me talk about it all the time. Walk machines. Go look at them. Go talk to people. Review the logs. If you don't have a CMMS, go talk to the last guy who touched it. Maybe he'll remember, right? You've got to walk the machines and look at them. We have to experience things in real time. We can't just go, I'm the maintenance manager and I sit in my office all day and I think this machine runs great. Meanwhile, the operators are falling all over themselves to keep the thing running at half the production cycle, right? So go out and talk to people. We need to understand the delta, the difference between the current state and the design intent. Okay. Let's break machines down, break down the machine, right? We want to deconstruct the machine into systems, subcomponents, parts, and detailed analysis. If you have PID drawings, if you've got parts breakdowns even, right? We want to know what parts go where. Sometimes, and I'm guilty of it, and I know, yes, Gemba walks. Very good, Ahmed. I'm guilty of it. And I'm sure you guys are too, where you go into working on something, maybe you don't have the diagram and you start disassembling. You say, oh my God, I didn't know there was a collar in here. I didn't know there was a dust seal in here. I didn't know there was a set screw here, right? By looking at these things and breaking the machines down ahead of time in your PM tasks, you are setting up your technician for success by uncovering the unknowns before they even start the work. Super, super important. All right. And then this is a huge one. Collaborate with maintenance, safety, operations, and quality teams to identify defects and gather feedback. It's very likely that there are things happening that you are not aware of as maintenance professionals. It's the death by 1,000 cuts. It's the things that the operator does every single morning during startup to get that machine to move. Oh, I got to move this proc switch a little bit, then it'll fire up. Or I can only run the belt at this speed in the morning or it'll fault. So I have to do this, right? Talk to people. Quality's in there because if we're producing something, they're looking at defects, right? Or our OEE, they're looking at the quality of our OEE, right? So if we're getting poor quality off, and that happens to be associated with a machine issue, well, we want to know that, right? Especially for like molding and dies and tool work and things. If you got an end mill that is wearing and you're getting a shattered cut and then it's not meeting the finish specifications of the final product, right? All that matters. All of you will have your own references to your day-to-day work that will make sense here. Okay. Develop inspection and maintenance tasks, right? We want to gather the data, create tasks and defects and prevent reoccurrence. And that may involve a design change. The reason that a picture of Upkeep is here is, well, we work for Upkeep. And it's very, very good to build out your preventive tasks in your CMMS. We want it to be laid out. Boom, 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 boom. What am I doing? Okay, pass, fail, measure, check, pass, no go, go, whatever, right? We want to then develop those tasks. And we're going to talk about that next. Okay. I know I'm talking fast, but this is such an important topic. I'm going to try to slow down a little bit. Amissa, am I going too fast?
You're fine. It's the more time we have for questions, the better, I say. So.
All right. Okay. Everybody still with me? Hopefully. We've got more people than we had when I started, so we didn't lose anybody. All right. Writing tasks for repeatability and detail. Okay. Question for you guys. What's the most confusing part of reading PM tasks? Now, we talked about the prior question was like big picture, right? What are the bigger things? Like think about the tasks that you see every day. What's the most confusing part or maybe misunderstood part that you see every day in the actual tasks that are assigned to you? Lack of task clarity is a good one. Yep. Not closing out and just repetition from that. Okay. No common language. Brady, you are in for a treat on the next couple slides. Deciphering the intent of the PM. Yeah, Sean, like by doing this, we're going to mitigate this, right? No feedback loop to planners. Oh, we're going to talk about that too. Difficulty of planning and scheduling using CMS. Ahmed, yeah, planning and scheduling is key, right? But tasks, man, what about the tasks? Refer to the O&M manual. Hey, your task literally just says refer to O&M manual. Man, they don't like you, Todd. Wow. Okay.
Might as well just put Google it in there.
Yeah, Google it, Todd. Don't bother us with those pesky tasks. Oh, someone who doesn't know what the machine does. Yeah, so that was like kind of my example, other Todd Burkhoff, which is like I'm writing this PM from Detroit and I've never seen the machine, but I saw the manual, so I'm just writing stuff, right? When task fails, linking to a PM and actions and changes required. Lily, you need to buy Upkeep. You can automate all that for you. All right. AI to do the PM. Good one, Greg. Don't get me all riled up. I'm trying to be professional here. All right. Well, moving on. All great answers. Okay. Here's the overview of this next topic of writing detailed inspections, right? So I'm going to read this because it's important. How we write and describe the work that needs to be done is only second to doing the right work. If we have a super detailed, awesome PM task, but it's the wrong task, that doesn't help us, right? We are so structured in doing the wrong stuff. Okay, keep that in mind. Our team rely on us to provide them with work instructions that are applicable, detailed, structured, and repeatable. We cannot leave such valuable work up to the varied experience, environments, and timing of our maintenance team and operators. We have to describe the correct work to do the right work. Okay, first bucket, language. One of you mentioned language. Well, I'm here to tell you I get it, and it's such a missing link in PM task creation. Okay, make sure the words you use and the way you phrase things are actually understood by your team. And here's my example, because conveyance often is misunderstood in component nomenclature, right? If your team calls a pulley take up, so a take up is the adjustment end of a conveyor belt to tension or detention or align or track a belt. If they call it a take up and you call it an adjuster, we'll talk to them, or you call it a take up, they call it adjuster, well then use pulley adjuster. Use the language that they are using and agree on. There's always room to educate on actual terminology, of course, right? We should call things what they are. And synonyms are okay as long as everyone agrees. We sometimes find that engineers write preventive maintenance tasks and use engineer language. This isn't going to help us, right? Some of the senior guys, or maybe guys that come from those fields, will understand that nomenclature, but the new guy may not. I've talked to many mechanics and I say, hey, we got to adjust the take up. And they say, what is that? I say, oh, it's the pulley adjuster. It's the tail pulley of this conveyor. What do you call it? Oh, we call it a conveyor adjuster or a pulley adjuster. Okay, great. That's what I'm going to write in the PM. Build consensus. Work with your team. Understand the language that is actually used in your plant. Super important. Number 2, task order. Structure tasks in a sequence that flows naturally, minimizing unnecessary movements. An example here, I worked on a lot of cranes, so I know this sucks. Start at the base of a crane and work your way upwards. I've literally had tasks assigned to me as a port mechanic where it says, verify and inspect drive motors on the gantry of this crane. And then the next task is grease the shivs in the superstructure. Why would we do that? You're creating a ton of wasted time for your technician, right? We want to start somewhere and progressively work our way logically through the machine to an end point, right? And if your PMs are structured this way, you will minimize not just unnecessary movement, but resources too, right? So if a guy knows he needs to bring X, Y, and Z, he's not going to lug it all the way up the steps just to come all the way back down with it, right? So that's super important. Task order. This is my favorite. I give this to a lot of people, but it's mine. You guys can use it, take it, run with it. Standardize the start and the end of your PM task. Someone had mentioned this. The start. In every PM task I've ever written, every single person I've consulted with, I always tell them to start the first PM task with, talk to the operator and ask if the machine has been performing its intended function, if they've noticed any anomalies, or have had to make any adjustments. That is a gold standard. You're literally interacting with the person who is in the machine or using the machine the most every single day. We want their input, because if we don't talk to them, we may miss very important things that are associated with failure modes that we've been experiencing, right? And it's a great way to build operator and maintainer rapport. And it's also a great way to generate corrective work that aids in your defect elimination strategy. You may not see the things that they see. And then by them telling you it, you're able to generate corrective inspections or corrective work to go and root out those failure modes. And then hopefully eliminate them altogether. The end of your tasks, input all necessary data into the CMMS and generate any corrective work orders discovered during your inspection. This is a end identifier saying, hey, you've done a wonderful job. Let's make sure we don't lose all of that information by not closing out our work orders correctly or opening corrective work orders associated with this work order. It's so important. It's a good practice for reminding maintainers to capture the great work that they have done. Take this, use it, just know where you heard it first. All right. Visual aids. Of course, you know me, there's an excavator. Sorry about my not straight lines, but that's just what it is. Okay. Images. A picture's worth 1,000 words, right? If I show you a picture of a machine and I got circles on it with numbers and they reference something that says this, and this, I can hand that to almost anybody and they'll know what I'm looking at. They might not have the industry experience for all the things, but they'll at least know what they're looking at to then become familiarized, right? Some things we don't do every day. So having visual aids in your work instructions or your task, super, super valuable. It helps bridge a tremendous amount of experience gaps, okay? We want to have arrows, circles, labels. We want to enhance clarity and reduce misinterpretation, right? And then the next page, we'll talk about why this matters. So step-by-step instructions. This example is in reference to the picture prior. So just keep that in mind. We want to have experience. We want to have tasks written that are understandable by all experience levels, right? We want to specify expected outcomes and potential defects. So basically what I'm saying is when we're asking them to inspect things, we're going to tell them what they should also be looking for, right? Not just check belt or check cylinder. So this is an example of a task. Verify that the stick cylinder is not leaking fluid by visually inspecting the rod, 1, gland, 2, hydraulic hoses, tube, and fittings, 3. And then we add an annotation as a safety precaution, right? Because there's a safety thing here. Do not use hands around leaking fittings. If you find a leak, a suspected leak, use cardboard to find a leak. If you see fluid sprayed all over the side of a machine, well, you know you have hydraulic pressure that's forcing that fluid out somewhere. We don't want to go run the machine and put our hand around a hose and get our fingers cut off. Same with high pressure fuel systems or any type of liquid or gas under pressure. That stored energy, there's a lot of risk there. Okay, continuing on. The rod, where it meets the wiper seal, 4, should be free of oil or damage, and the threaded gland should be seated and dry at the threaded seam. All hydraulic hoses and fittings should be clean, dry, and free from damage. Should leak be found at rod or gland, please reference the breakdown for parts identification. So if we go back, there's the numbers referencing the rod, the gland, the barrel, the rod seal, and the hydraulic hose connections, right? And the step-by-step instructions is super important. To take it a step further, I didn't add in here. We might talk about it next, but is adding, what specific tools you may need, of course, right? We're going to have that bill of materials that includes, you're going to need this wrench, you're going to need, whatever. But the step-by-step instructions is key, telling them what they should be looking for with expected outcomes. And then also having that reference material to go back to should they need it. Okay, this goes in the same line of thinking. Preset kits, right? We want to define the required tools and parts in advance to streamline our execution. We talk about running around. We'll use the crane example, right? What if our PM task orientation is all jacked up and we also don't have the right tools? So now you've gone up and down a crane 3 times and you still don't know what tool you need. So we're compounding the effects of poor mean time to repair, right? So we know something's broken or we have a scheduled outage and we need to perform all these tasks. Well, you're compounding that time. You're delaying that time more by not giving the technicians and the team all of the information you can up front so they can become prepared. It's all about being prepared, right? This is an example in upkeep of a parts kit. I don't know why I put cart there. It should have said CAT 308 bucket cylinder hoses. But this is an example of the hoses that would be associated with that task. So he knows, okay, we're changing these hoses. I know exactly which ones I have. They're already assigned to my work order. Bang, moving on. I don't have to run back and forth. Oh, is this the right part number? Oh, let me look this up. Let me call this person, whatever. No, it's already there. And then you notice how with the parts names, they were identified as extension and retract. So if you understand hydraulic cylinders, which you would through your PM task, you would know where those hoses go. Safety considerations. We touched on this a little bit. Clearly highlight safety precautions, like my example with using cardboard on hydraulic, but it also is about utilization of various testing techniques and PPE. If something is required that has a threat or a risk to life, EHS, compliance, make sure it is called out in your PM task. Because the minute something bad happens, they're going to ask, what did you do? And what instructions were you using? Okay? We all know this. Keep that in mind. Okay. I think we made pretty good time. Closing thoughts. PM task creation is super important. We want to put as much efficiency and effectiveness into the hands of the people performing the work as we can. We don't want to muddy it and have it to be where you got to figure it out. Now, those times will come. That's just the way that it is. But the more we can proactively create for our team, and the more we standardize and create repeatability and have the level of detail required to achieve the desired outcomes, the better off we will be, not just as planners, maintenance managers, maintenance technicians, whatever, but as a organizational unit and a business. All right. Questions? What do we got, Amissa?
All right, let's take a look here. So we have one question that came up during the talking about age for PM tasks. So is age where we also run into a lot of obsolete parts and difficulty finding replacements?
Yeah. So that was the example that I made with, a lot of older company manufacturing, specifically, industry, that are running a lot of older or obsolete machines, specifically machine tools, machining, milling, stuff like that. They have tool and die makers employed in their facilities. So they're literally making tools, dies, parts, and things to keep their old machines running. Old machines inherently, there's going to be things that you just cannot get anymore. So you either have to do references, cross-referencing old part numbers to new or like specifications, and all that. So it takes a bit of know-how to get that stuff done. But yes, age is also a part of that. That's a huge one. What else?
I don't know if this question was meant to be in the specifics and confines of tasks specifically, but looks like they're just wanting you to discuss maybe the differences between preventive maintenance and predictive maintenance.
I get it. Yeah. So predictive maintenance is preventive maintenance. No one likes to hear that, but it is, right? You're doing something proactively to mitigate risk or mitigate a failure. And a prediction or condition-based maintenance is looking at the real-time context of a machine. And then you're making your maintenance actions prescribed to the real condition or risk associated with that machine. It's still preventive maintenance, in my opinion. I hope that was good enough for you. But yeah, you can write, if he's asking about predictive or whatever, condition-based routes, same thing. If you're writing a condition-based maintenance route, maybe you're taking temperature readings, thermography, maybe you're pulling samples. Well, set up that route that makes sense for the technician. Don't make him run to one end of the facility, then back to the front where he started to pull an oil sample, then go back and forth. Yeah, make it flow through the facility. In upkeep, and I know several other CMMSs, you can put in floor plans inside the system, and then you can literally develop where they go, right? So the technician can look at the physical floor plan of their facility, and you can set a route based like that.
Okay. Caroline, are you an upkeep customer? She says, I want to create a PM per room number in a hotel and have the system alerting me when it's due again. Can you show how that would look? Obviously, we're not going to do a demo right here, but if you're an upkeep customer, I would recommend reaching out. If you know who your customer success manager is, shoot them an email and they gladly walk you through that and help you get that set up. Or if you don't know who that person is for you, email me directly. I put my email in this chat, and I will get you connected to that person who can help you get that set up and give you the directions on how to do that.
You can do that. We're not. Yeah, they're
we're not doing it during this webinar.
Yeah, they're way better suited to have that that set up for you.
Yeah. Let's see. I'm trying to go through here. Matt said, I thought this regarding important PM tasks and upkeep. I'm not sure what that means.
I think we might have got some questions that were supposed to be in the chat.
Yeah. I see. Okay. Here's some more questions. Got it. Sorry. I was looking at that. All right. Could I get an invite to one of your future webinars where you demonstrate your PM? Okay. David, if you are a customer, email me and I'll get you connected and we can give you one-on-one help on that. If you're not, you can still email me and we can help you. Let's see, Todd. When do you calculate the end of life on a piece of equipment?
Okay, well,
Or when do?
when to calculate.
Okay.
So, look, in theory, if you are purchasing machines or you know the value of machines, you can leverage your what's called replacement asset value. So essentially, what you're looking at is you're looking at the value of the machine, whether new or its current state, versus the amount of money that is spent both preventively and correctively on that machine, whether it's in man hours, in spare parts, whatever. And you get to a certain ratio to where it's now not cost effective to maintain that machine anymore versus its value. And in which case you replace it. That's the simplest way without going crazy into detail. That's a better question for another time or another webinar, but replacement asset value is the easiest way to do that.
And then John was wondering, is there a way in the PM format in Upkeep to see things like when the filter was last changed or a belt or other parts, like historical information?
Yeah, you can see parts consumption right on your work order. If your technicians are leveraging, they're assigning parts to their work orders, you go into those work orders. You can actually filter work orders by parts too. And you'll be able to see what parts have been consumed, the dates with the work, all the information will be associated with the work order. So yes, if you want more information on that stuff and you're an Upkeep customer, contact your customer success manager. They can show you all those things in detail with Upkeep up on the screen.
Yeah. And like I said, if you guys don't know who your customer success manager is, I mean, some of you probably are communicating with them and know them. If you don't, though, email me and I will make sure you get connected with them. All right. Biggest challenge for me to carry out proper maintenance of our machine is that all the production managers and operation managers want to have machines running all the time.
Okay, so this is my question to you. Philip, are you the maintenance manager or are you a technician? If you're a technician, you need to go talk to your maintenance manager. Your maintenance manager should be building relationships with operation and production leadership because it is invaluable for both of those departments to have the relationship so that they understand I'm here to maintain your machines so that you can produce the things you want to produce out of them. If you do not allow me to maintain my machines, I cannot guarantee their production capacity. So it starts at you as the manager. It starts at building a relationship and not pointing a finger. If you recognize that you have poor maintenance practices, you need to own it, talk to the team, talk to other leadership, figure out what the problem is, and start course correcting. I always say this, I've been a maintenance manager, I've been a director of maintenance, I've done all those things. I'm never going to point my finger outside of my department until I've pointed it sufficiently inside my department. So it relies on leadership to build the relationships and do the right things. You cannot have a production facility if you do not maintain assets. And planning and scheduling is going to be your best friend. And getting that planning and scheduling signed off by those particular managers with constant review is going to be even more of your best friend.
Yeah. Shamika asked, how effective is having a checklist/dynamic checklist with your task plan?
Not sure I understand. Well, having what I don't understand what they mean by dynamic checklist.
Shamika, what do you mean by dynamic? It could be the CMMS that my company uses. Never mind. She said. I mean, I think there is like checklists or task lists associated with PMs in a CMMS, typically, right, Brian?
Yeah. I mean, a checklist is like the body of tasks, right? If you say I'm creating a checklist, inside the checklist we'll have tasks, right?
Mm-hmm. And then maybe you could just talk to maybe like the importance, or I mean, because making your checklists or your tasks effective, right? Like not just having them for task's sake.
Oh, so Shamika, I get what you're saying. So you're talking about like pass fail, right? You can set up automated workflows where if you fail a task or flag a task, then it becomes a notification to leadership that there's an anomaly, something needs to be addressed. Yeah, okay, I get what you're saying. Super important. That's a pinnacle to understanding your corrective work generated by preventive work, right? So if our preventive maintenance tasks are working, then we're finding problems, right? We're replacing things. We're doing the right work. We're finding issues that we're addressing. If our PMs you're just doing PMs and you never find a problem, that's a problem. Or if you're doing PMs and all you do is find problems, that's also a problem, because now we're not actually solving issues. We're not engaged in defect elimination. We're not engaged in actively and proactively repairing things. But having those automated workflows where people are brought abreast of flagged work orders or failed tasks, that's important. Upkeep does it too. I always recommend it. It's very important. It keeps you from dropping the ball, essentially, right? It takes the variability out of you having, or anybody having to be like, oh, I just forgot that this was wrong. Well, now you're behind, right?
Yeah.
Well, Shamika, so are you an Upkeep customer?
Sounds like she is using a CMMS, so I don't know if it's Upkeep or not.
All right, so Catherine, the issue that task triggering, does it operator tech? Yeah, so there's going to be some variability there, but in theory, operators should be requesters in Upkeep, not technician users, unless you're setting up Upkeep for operators to do like pre-start, pre-check-ins, pre-operation inspections. Yeah, okay. I get what you're saying. We can take a deeper look at that, but it's good you're using them. It's good you're using that for operators to do pre-use inspections. You just got to make sure you build that relationship, especially the technicians, so that things that are being flagged as an issue they go away because your technicians are talking with them, you're modifying your PMs, and you're addressing those things, and then it becomes not even a point, right?
Okay. Well, let's see here. Let's see if we have any more questions over here that I missed. I think we've gotten all the questions in the question feature. Let's see here. How about post-use or end-of-shift operator inspection, breakdown, clean, etc.?
Those are normally in the operator's SOPs. The difference there, operator SOPs will generally have a setup, depending on the industry, right? You'll have a setup procedure and you'll have a breakdown procedure, right? At the end of the day, say food manufacturing, at the end of the day, we're going to clean all debris. We're going to sanitize. We're going to pull the acetyl conveyor belts. We're going to put them in the hot tank. They're going to get washed. So that's all SOP based. But the key there is ensuring that the maintenance team is involved in the relationship with those operators, so that they can communicate variability in those SOPs and processes, so that maintenance is aware of.
Okay, well, I did put, if you're not an Upkeep customer, I put a link to a free trial if you want to try it out in the chat. Also, if you are already using Upkeep and you want help with fine-tuning your PM task creation or your PM in Upkeep, email your customer success manager or reach out to me and I'll make sure you get in contact with them and they can help you. Also, I'm going to do a little plug because we are having another webinar in April. We do one webinar a month, and next month's webinar is about AI and maintenance. And if you're interested in that topic at all, I'm going to put the link in the chat right now to that webinar registration page. You can read what the webinar is going to be about. If you're interested, feel free to register for that as well. If not, that's okay too. But we really appreciate you all showing up today and giving us the time to talk about effective PM tasks. And yeah, email us if you have questions. We really want you to be successful and we want to help.
Yeah. And we, a defining thing for Upkeep, is we understand the reality of maintenance, right? We are a software company, but there's a lot of CMMS companies out there that are all about the data, the this, the that, and they lack experience in the real world of maintenance and reliability. And Upkeep, we have that. We pride ourselves on that. So if you're looking for sustained value in your CMMS, we are equipped to not just help you with CMMS and technology, but we're equipped to help you with the reality of your maintenance functions. So.
All right. Thank you, everybody. Hope you have a good rest of your day.
Thanks, guys. See ya.